2.9, we're just going to talk about some more rules in math. So if I have this chart here, I'm looking at my expression. I want to know what are the numbers or what are the objects in my expression that are being combined and what operation is being done to them. Okay. So in my example of A, I have the square root of 17. So my object is just the number, what I'm looking at, right? And the operation that I'm doing is taking the square root of that, right? So if I have 4 2/5, I have 4 2/5 as my objects. And what operation am I doing to combine those two numbers?
Multiplication and division.
So if I was just looking at 2/5, that would be multiplication, or that would be division, right?
Mm-hmm.
But I'm looking at these two. So how am I combining those two numbers? So what do I have to do to those two numbers to get to 4 2/5? So the way I would look at it is to get to these two numbers, or starting with these two numbers and getting to this. So 4 2/5, 4 2/5 is equal to 4 2/5. So I'm saying, what operation do I have to put right here to get to this? Well, I just need to add those together, right? So if I add 4 2/5 together, I get 4 2/5, right? So my operation here, it's not really shown, but it is addition. Okay. And then part C is kind of like what you were talking about when we were looking at the fraction, right? So we have 8 and 9. Well, what are we doing to 8 and 9? We are dividing them. So division. I have the part D, I have the absolute value of -10. So the operation here is the absolute value, and the object is just whatever's inside, which is the -10. So my object is -10. My next one, I'm squaring something, right? So I have -8 quantity squared. So the object is inside the parentheses, which is -8, right? So the -8 is the object being squared here. If I look at the next one, I have the negative of 8 squared. So I'm looking at the operation of squaring, and what I'm squaring here is just the 8 itself. So I'm taking the square of 8, and then I'm taking the negative of that, right? So my object here is just 8. It's not -8. Okay. The next one, I have 2 multiplied by the quantity of x plus y. So the object here is, or my operation rather, is multiplying. So my objects are the two things that I'm multiplying, which is 2, and then my other object is x plus y. So I'm just specifically looking at the things that I'm multiplying together, which are those two. Okay. On the next one, I have a plus b over 2. So my objects are a and b. So what is my operation? So what's my operation here on part H? What am I doing to a and b?
Addition.
Yeah, I'm just adding those two together, right? So I have addition for this one. Okay. Part I, I'm looking at the top, so a plus b, and I'm dividing it by 2 again, right? So it's the same thing as part H, but my objects are a plus b and 2, right? So I'm dividing those two. So my operation here is a division, or is division. Okay. And similarly, part J, I have a over 2 plus b over 2. So my objects are a over 2 and b over 2. So my operation here is just addition. We're just looking at what those two objects are doing. This one's addition. And then finally, part K, my operation is division. So what are we dividing in part K? What are my objects?
A over 2 and B over 2.
Right, so my objects is A, b, and 2. Right? So we could write 2 twice if we wanted to, but we don't have to, right? Because 2 is the same thing in either one. So my 3 objects are A, B, and 2. Okay. So when we kind of look at part G, we see that we can use the distributive property with 2, right? So what if we have something like, this part right here? So it says, suppose that you want to half a recipe that requires 4.5 cups of flour. So we can take half of 4 and take half of half and combine them, right? So what I'm going to do is I'm going to split this fraction up. So remember on part B on our chart, we said that these were adding each other together. So what I'm going to do is I'm going to split this into 4 over 2 plus 1/2 over 2. Okay. So this fraction on top is the same thing as adding those two together. So we have 4 over 2, which is 2, plus we have 1/2 over 2, which would be 1/4. So if we split them together, divided by 2 and then added them back together, we get 2 and 1/4. Well, is 2 and 1/4 the same thing as 4.5 over 2? So are these equivalent expressions?
Yes.
Yes.
They are, right? Yeah. So we can either split them up like this and divide them both by 2, or we can just take the first one and divide by 2, right? So we're kind of distributing this division by 2 to the first and second part in the fraction, right? So in general, you can do that with anything. So if you have 2 things in your numerator, you can distribute that 2 so you're dividing both of them, right? So what they did here is, I'll rewrite it over here. So if you have A plus B, or just 2 things on top, and you're dividing it by 2, that's the same thing as dividing A by 2, and then adding to that together with B divided by 2. Okay? So that's all that's saying, is we can split apart the numerator and divide them both by the denominator. Okay? So an example that they give, it says simplify 4x plus 1 over 4. So I'm going to do this case up here that we can split them up. So I'm going to say I have 4x over 4, and I'm going to add that to 1 over 4. So I'm just splitting up the denominator. So what is 4x divided by 4?
X.
Yep, just x. And then we're just adding 1/4. So all we're doing is just splitting up that numerator and just dividing by the same denominator. So this x plus 1/4 is the same thing as 4x plus 1 over 4. They're the same thing. Okay. All right, anyone have any questions over this first page? All right. We will go on to the next page then. So we're going to use that rule again, where we can split up the numerator to simplify these expressions, right? So what I can just say is that I'm dividing the first part by 7 and the second part by 7, right? So 7x divided by 7 is just x. And then I'm going to add to that 7 divided by 7, which is 1. So I get x plus 1. Okay. And then I can do something similar for b. So my general rule was if I have a plus b over some fraction, I'll just put 2 again, I can split that up into a over 2 plus b over 2. But this time I have a subtraction, right? So can I do this same rule that we have if I have a subtraction sign instead of an addition sign?
Yes.
Yeah, because it's just like adding a negative number, right? Because we could rewrite this as x plus a negative 7 over 7, right? So we could just add a negative number instead of just subtracting. So these two are the same thing. So yeah, so I'm going to have x over 7 if I split this apart, x over 7 minus, I have 7 over 7, which is just 1, right? So x over 7 minus 1 should be our final answer for B. Okay, so part C, it looks like I have the negative of part B, right? So I'm just going to substitute in what I had for part B. So this fraction bar, so I'm going to take the negative, and I'm going to put parentheses just to make sure this is more clear, because I have the negative of whatever this is. So I have the negative of part B, which is x over 7 minus 1. Okay? So that's just making clear that we're taking the negative of this whole fraction bar. Okay? So I have negative x over 7, so I'm distributing this negative sign. So negative x over 7. And then the negative of a negative 1 is a positive 1. So I have negative x over 7 plus 1. So that should be part B. Or part C, rather. Okay? So what if I have, instead of having a plus b over 2, can I have 2 over a plus b? And that be the same thing as splitting up the denominator. So what if I have, let's see. So these two equivalent expressions, or supposedly equivalent, I want to show maybe a counterexample. So an example that maybe that this is wrong. So what if I do, let's do A is going to be equal to 2, and B is going to be equal to 3. Okay? So those are just random numbers, but they're pretty simple and easy to work with. So let's plug in those two values for the left side, so the 2 over A plus B, and let's plug those two values in for the right side. Okay. And actually, I'm going to make B equal to 4. It'll just be easier to add them here in a little bit. So B is going to equal 4 instead. So let's plug in 2 and 4 for the first side. So we have 2 over 2 plus 4. Right? So what is 2 over 2 plus 4?
1/3.
1/3, right? It simplifies to 2/6 and then goes to 1/3. Yep. So that's equal to 1/3. And then on the right-hand side, where I have 2 over A plus 2 over B, well, I have, let's see, 2 over 2, if I substitute in A, plus 2 over 4, if I substitute in B. So are these two fractions added together, are they the same thing as 1/3?
No.
They're not, right? I get 1.5. Yep, so they are not equal. Right, so that's a counterexample that we could use to this. So this right here is not the same thing as this one over here. Okay, so they're different things. You can't do this. This is the only time that you can do this is if we flip it, right? So if we have our numerator where we have two things divided by 2 or divided by some number, we can do that. So you can't split up your denominator, but you can split up your numerator. Okay. Okay. Any questions on those so far? Okay. If not, we'll move on. So this one says, evaluate each expression when n equals 5. List the operations that you applied to the value of n in the order they were applied. Then provide a second list of operations that contains the inverse operations in reverse order of the first list. These operations undo the original set of operations done to n. So basically what we're going to do is we're going to solve this or substitute in our value. We're going to list the steps that we did to find that value, and then we're going to say how we could work backwards, okay? So this will be important for the next section, I believe. So it's kind of important to get into that habit. So what we're going to do is we're always going to say n equals 5. So that's going to be the very first thing I do, is I'm going to substitute in 5 for n. So I'm going to have 3 multiplied by 5. I'm going to substitute in the 5 squared minus 2. So what's my first step into solving for this expression right here, simplifying.
And the exponent?
Yeah, the exponent, right? So the first thing I'm going to do is I'm going to square 5. I'm going to kind of write it out to the side here. So the first thing I'm going to do is square 5, which is 25. So I have 3 multiplied by 25 minus 2. So what's my next step? Multiplication or subtraction?
Multiplication.
Yep, multiplication. So I'm going to multiply. And I'll just write multiply, which is 75, right? So we have 75 minus 2. And then 75 minus 2 is 73. So my last step is subtracting. Okay. So my last step is subtracting. Okay. Now I want to provide a second list, and I want to do that in such a way that we have the inverse operations in reverse order. So subtracting is here. So what's the inverse, or what's the opposite of subtracting?
Add.
Yeah, I'm going to add. And I'm going to add 2, right? So what I'm going to do is I'm adding 2 to get back up to 75, right? So what's my second step? So instead of adding, which was subtracting, right? That's the inverse. So what's the inverse of multiplying?
Divide.
Divide, right? So to go backwards, I'm going to divide by 3. So we kind of go backwards to this step, right? And then instead of squaring, what's the opposite of squaring?
What is it? I don't know.
It's square rooting, right?
Okay.
Like this, like that symbol right there. It's square rooting. So the opposite of squaring is square rooting. Okay. So basically what we're doing is we're just going in inverse order to kind of keep working backwards to the start up here. Okay. We're kind of just working backwards. So if I write these operations out, so I'm going to start with 73. I'm going to add 2 instead. I get up to 75, right? I divide by 3, so instead of multiplying by 3, I go down to 25, right? 75 divided by 3, I get back to 25. And the square root of 25 is 5. Right? So I'm kind of working backwards to find out what the value of n is in my equation, right? So we're just kind of doing the inverse order. Okay. So let's do 2, but I'm not going to make you write out everything again because I think that's it gets very tedious. So let's plug in our value of n, which is 5. So I'm going to plug in 5 for n. So I get 2 multiplied by 5 minus 1 over 3. I'm just plugging in 5 for n. So what's my first step here to simplify this?
2 times 5.
Mm-hmm.
And then 2 times negative 1.
Yeah, so we can distribute this, right? So we can distribute it, or we could just do what's inside the parentheses, right? So we have 2 options. So we could just do 5 minus 1, which is 4. 4 times 2, which is 8. Or if we distribute the 2, we get 10 minus 2, which is also 8. All right, so we get 8 on the top, and on the bottom we get 3.